All right, I think we can get started here. Hi, everyone. My name's Eric with BobCAD-CAM. I am one of our technicians here. I am the demo technician with BobCAD, so doing demonstrations of the software program for potential customers, doing tech support, answering any tech questions you guys may have, and also doing training now as well, including the webinars like we have today. We have webinars every other Wednesday live at 1 o'clock p.m. Eastern Time. I'm also doing some training sessions with online training where you could book an hour or a 2-hour session with us, and we'd be able to help you program your parts for you, whatever you need in the software program. Today with the live event, we'll be going over mill turn. And so if I flip this part over here, sort of look at it from the beginning that we've got here, we'll be doing some basic turning functionality first, and then some milling operations with the live tooling. So first we'll be doing the facing here with a lathe and turning on the OD. Next we'll be milling around this hex, and then next we will do a milling on the side of the part. If your mill turn machine, your lathe with live tooling, is able to do a pocket on the side like this, we'll be getting into using the y-axis. If your mill turn machine has that, we're able to offer that as well. And then we'll get into a basic part transfer operation as well. So I've got a mill turn already created here, but I'm going to minimize that, and I'm going to create a new mill turn job from scratch. Before I do that, we'll take a look at, basically how I created this part file. I just really went into Create 2D, went to our shape library, and created a hex right here. Created the size, looks like it was just the default size there. And then extrude boss that, create a couple circles and extrude boss those down from the hex there to create my solid model. I also went on the other side, might be able to get into doing the part transfer and doing turning on the other side with the sub spindle. But yeah, I just created another circle and an extrude cut there. With that, I have to create the wireframe to be able to select that as my geometry for turning operations. And a very easy way to do that in BobCAD from a 3D model would be first going to my layers over here on the right hand side, right clicking, going to add new layer, and I'm going to name it wireframe 2. And it's going to be active with that green check mark. We'd be able to go to the top, go to create 2D, and this function over on the right hand side, spun profile. I would select that. I would just window select my whole 3D model. I think it's around the z-axis is what I'd be selecting here. Let me test along x-axis first. Yeah, along x-axis is not what I want. It's somewhere out there in space. So I've got my part file around the z-axis. So I have to select along z-axis, select my solid model, and then click OK. And then when I hide the layer that the CAD layer is on, the 3D model is on, I can see the wireframe that I can work with to select this vertical line for my facing operation, and then to select the profile of the part, the wireframe here, to do a turning operation, turning on the OD here. Excuse me. All right, so we will get started here once I've created my CAD file, my 3D model. I've got my wireframe from any 3D model that I create or I import for my turning operations. I go to the top and I go to CAM and I start a new job. And we'll be selecting mill turn. It'll be the third one down here, and selecting the machine. Now, the default machines here are all of the ones that start with BC. That stands for BobCAD in the software program here. So for BC, we've got our BobCAD 1T1S for the first one. That stands for BobCAD 1 turret, 1 spindle. We've got BobCAD 1 turret 2 spindles, so this one has a sub spindle. BobCAD 1 turret 2 spindles with a y-axis. And we'll get into BobCAD 2 turrets, 2 spindles. We can have any kind of configuration like that. I actually learned recently that we could have more than just 2 turrets and 2 spindles, but that may be for a later date. You can see that I have some other mill turn machines in here. We've got some Haas mill turn machines. We've got a Kia mill turn machine with a Finna controller. These are not built into the software, but they are ones that we created. I can show you a little bit in the machine configuration how we can model the STL files for your specific mill turn machine, and also getting set up on setting the limits. Now, we don't really get into that. I should say customers don't really get into that for creating their own limits and creating the configuration, because that's mostly done in-house here, where our post-processor department creates the post-processor for you and also helps create the machine file and configuration so that every rotary axis is configured correctly. So to do that, I'm going to show you real quick. To get that started, if you haven't done that yet, you go to BobCAD-CAM and you can request a post-processor and request the mill turn configuration here at BobCAD-CAM, going to post-processors and going to request a new post-processor. It gives you a video on how to request one. Scroll down, scroll down, scroll down. We've got, let's see, I usually do a PDF form, easier that way than the web-based form. And I'd like to be able to save it as a PDF on my computer. And then you can go all the way down to post request forms for mill turn. You would download the correct one. So mill turn with Z-axis oriented milling spindle, or a mill turn with X-axis oriented milling spindle. And then once you download the form here, it gives you a whole lot of questions about, well, how's the calculate the position for us of the milling spindle, and some other information as well up at the top for your you type in your customer name, your customer info, company name, and you type in the machine make and model and those kinds of things. A little bit further down, you type in the travel limit for each axis, so we make sure that there's no collisions with the machine, and make sure everything is properly configured. Number of positions on your turret and things like that. So that's a quick overview on how to request a new post processor and your machine for your mill turn machine there. So I am going to, if you guys wanted to follow along today, I basically, again, just created a hex, created a couple circles, and did an extrude boss here. For my machine, I used the BC2T2S. So that is the BobCAD 2 turret, 2 spindle machine, so that we can get into some part transfer programming today as well. We go to the stock wizard. We can define the workpiece here. Our next page is where we can define our stock. So we've got our rectangular piece of stock, we've got our cylindrical piece of stock, and we've got wireframe, so we can extrude from wireframe. We can select an existing solid model or STL file. These can be helpful, especially here if we're working off of a casting and starting from that, we can define it as an existing solid model that we're starting with. Avoid any air cutting there. Excuse me. All right, so you can see that I did the extrusion in the Z direction. With the stock, the extrusion direction is in the Z axis. Mill turn, you can do this in the basic lathe functionality. It's a little different configuration for the part file. For mill turn, you have a little bit more control of wherever you want to define your stock, and on the next page, wherever you want to define your machine setup. Now this is really easy because I've got my machine setup configured in the exact same way I have my CAD origin location, so I don't have to really mess around with that. But then we'll get into defining the machine setup on the other side once we do our part transfer there. But here, if you have your part file configured a different way in the software program, orientated a different way, you can always go here to your origin location on the left-hand side in the data entry box here. You can click on a new origin location. Let's say, just real quick, if we did it on this side, click on that point. And I would need the Z-axis pointed the opposite direction, so I can either select a point or a line in the Z direction from highlighting this box, or I can click on the reverse direction arrows to reverse the direction like that. I'm going to reverse it again so that I can get it right on the front face of my part here for the main spindle. And then I'm going to scroll all the way down, and then I'll get into this as well real quick. We've got our work offset number 1 is G54. We set it to 2 is G55, 3 is G56, and so on. And right below that, we have our work offset in X, Y, and Z. So this location that I have of my work offset currently is going to be located at the front face of my stock, in line with the front face of the spindle or the chuck. So if I am needing to, which I am, needing to push out the stock a little bit further out of my chuck, I have to get the length of my stock here, which is 6 inches. And I would type that in here for work offset XYZ. So I'm pushing it out of the chuck a certain distance here with this Z value. If I type in 6 in Z, it's going to push out the stock all the way out of the chuck there that I see in simulation. And as a side note, this work offset XYZ parameter here is only going to change the parameters in the simulation. It is not going to change anything within the G code. Then I will click OK down at the bottom. I'm going to delete the mill turn job that I just created and work off of my existing one, just in case I forget anything. We'll go to machine setup 1, and I have it at 6 inches, and my part file is 4 inches. So it's got some jaws that are a little bit further out that it's going to clamp on. So we'll take a look at that in simulation there. For my stock, I have a little bit out in Z for a facing operation. So if we go in there, I added on the start face, I added 150 thou. And then for my machine setup, it looks like on top of the stock there. So from there, I can right-click on Machine Setup 1, and it's going to be the same exact workflow as in milling and as in with turning. So I right-click on Machine Setup 1. We have our mill features, drilling, tapping, counterbore, and 2-axis. And then we have our turn features. We're going to be doing our turn features first. We're going to be doing lathe end face. So I'll select that first. I'll select my geometry. And I'm going to go to my wireframe layer, and I'm just going to click on this vertical line right here to end my facing operation at that location. Then I click OK. Next page, all the same functionality and parameters as we would have for a facing operation in the turning job functionality in BobCAD. You can see I'm either starting from region 1 or region 2, starting from stock or starting from a custom distance. Next page, we can do a rough and a finish pass. Next page, we can do output in separate moves or in CAN cycles. And then our next page is setting up the roughing tool. The tool insert and the tool holder. We can output in RPM and constant surface speed. You'll see all of this is the same page as the turning job, but you'll see a little bit different here once I go to the tool crib. You can see it opens up the mill turn tool crib here. And we have a turret with different station numbers. So we've got 16 station numbers in this turret here. Excuse me. And normally, what you'll see on your page if you're following along is your tool will start in the loose category down at the bottom here. You would expand that option and you've got your tool here. You would drag and drop it into any of these station numbers that you would have on your turret. Now it's going to be this tool number for me, station number 1. And you can see it's orientated this way, so sort of like this, where this turret's going to come down like this, the tool is going to come down and do the facing operation like that. You can see the mounting orientation for me is mounting orientation 1, but there's your 8 different mounting orientations, whether it's a left hand or a right hand tool. And these tools are pretty rudimentary, I would say, here with the tools on the turret, because you do also have an option to highlight, for example, station number 1 here under upper turret. And then down at the bottom, you can add from tool library, and you can also add from adapter library down at the bottom here. So you can add an adapter first, and then add the tool stationed into the tool adapter, whether it's a turning, facing up. Let's see, we've got different adapters in here. Face milling adapter, boring bar adapter, cross mill adapter, turning tool X adapter, and dual mill Z adapter. That's for VDI adapters. And then there's also side mount adapters, turning tool in X or Z, face milling, cross mill, 4-axis mill, boring bar adapters. And you can also add an adapter and import an STL file to define your own adapter in here that you need. I'm going to go back to my own feature that I have for my facing. And here's the tool that I'm using under station number 1. And then I click OK. Now you can see maybe on your side also it might be sticking inside of the turret. I had to move the tool out of the turret, so it was actually sitting inside of the turret like that. To push it out of the turret, basically I'm moving it in the negative X direction here, and I moved it negative 4 inches in X. And that's how I moved it out. You can also move it, in relation to the adapter if you need to move it in, let's see, it would be like in the Z direction if I need to move it, negative 2 inches in Z. You can see it coming closer to the front face of the stock there. So that's how you can configure your tools along with your adapters onto the turret here for your mill-turn programming. And so from there, we'll click OK. We'll go to our next page. And now we'll get right back to all of the same, basically the same workflow as in a turning job. Where you've got your standard pattern or offset from the geometry, your standard sorting or zigzag back and forth, your collision detection, your machine compensation as well for G41 or G42, your depth of cut, your finish allowance. We're doing a 50 thou depth of cut for each pass and leaving 10 thou for the finish pass to clean up. Our next page, our rapids, where the tool is going to wrap it from, where it will wrap it back after the operation, and our lead in and our lead out page. Next, we'll be getting into advanced feed rates. So for every turning operation, if we're not able to set a rapid rate at the controller, we can change the rapid moves to feed moves, and we can set that rate here manually. We can also set our feed rate for our lead in and our lead out manually. I haven't had a whole lot of customers really utilize this from what I've heard, but the only thing that I've heard that could be beneficial maybe would be like setting a slower lead in to sort of ramp up the feed rate from lead in into cutting. I suppose that could be helpful. So we go to our next page, and our last page here is MDI. This is for manual data input. So if there was any additional G or M codes you wanted to add before or after an operation, you can do that here. You can also add, let's see, if I scroll down with all of these options in mill turn, we've got a few more options than in the milling or turning here. You can see like we have part transfer and part catcher. We have tailstock. We have raw text. So let's say I highlight raw text. This is how we use the MDI page. I would highlight raw text first. I would highlight before tool change. And then I would click command right here. And now you can see down at the bottom, it says raw text. You can enter anything you want here. If I type in test comment, it will print just that in the G code when I post the G code file. If I click on comment, it will add parentheses before and after the text so that I don't have to add them in myself. And then our next page, we're setting up the tool for the finish pass. I'm using the same exact turning tool. So I don't have to go into the tool crib and define it. It's already referenced as station number 1 here. We go to our next page. We're doing a continuous finish pass. We're alternating back and forth horizontal versus vertical and turning on collision detection. So again, just all the same workflow as we're doing a turning, roughing and finish operation, turning on the OD of a turning job. We've got parameters, our rapids, leads, advanced feed rates, and MDI page. So I'm going to hit compute. We've got our facing, rough, and finish programmed here. Once it computes. And it's blanked out, so I'm going to show the toolpath for that only. And then we'll get into the next operations here after doing the rough and finish for facing. We'll be doing the rough and finish for the OD. If you guys have any questions, please let me know in the comment section. More than happy to help and answer any questions through the live event today. I can also answer any questions at the end if it maybe gets too technical there. So we've done the facing. Next, we're going to be doing the turning for the OD here. So I would right-click on Machine Setup 1, and then go to Turn Features, and go to Lathe Turning. Then I'll select my geometry. I think I can look at a top view, right? No, not in the top view. Not anything too great. That might be where it could be beneficial to have your model, your 3D model and your wireframe modeled the same exact way it would be as if you're looking in a top view, to be able to view it here like you're doing for a turning job. But you can model it however you want here. I'm just going to sort of revolve it around to be able to see the wireframe I need to select for the turning of the OD. I'm going to window select these 3 lines and window select these last 2 lines here of the OD, and then click OK. Go to my next page. I'm turning on the OD rather than on the ID. We also have front face and back face turning as well here. We go to our next page. We'll be doing a rough and a finish, so I just select it from the top here and go to my next page. We can now put in separate moves or in CAN cycles. This would probably be the most beneficial to use CAN cycles in for a turning operation, sort of like a subprogram or a subroutine kind of to shorten up the G code for turning operations. Then we go to our next page, and we're setting up the tool. I thought I was using the same tool. Let's go to the tool page. Yeah, I should be using the same tool under station number 1. I'm going to click on that tool and then click OK. My next page, turn on collision detection. Oh, I'm in a new feature here, that's why. Turn on collision detection. Set up my depth of cut, set up my finish allowance. I'm using the same numbers as with my facing, just doing 50 thou depth of cut, finish allowance of 10 thou. Next page, rapids, leads, advanced feed rates, and MDI, same pages as within the facing operation. Next, I'm going to be selecting the tool for my finish operation. And I tend to go to the tool crib, click on the tool under station number 1 just to double check and make sure I'm using that correct tool that I want to use. Next page, same as doing the facing operation, continuous path for my cut pattern and turning on collision detection. Parameters, rapid. For parameters, I'm leaving it at 0 because this is my finish pass, and I'm not leaving anything for an additional pass. Next, rapids, leads, advanced feed rates, and MDI, just as we had for the facing operation. So you would hit compute if you're going to be following along. I'm going to hit cancel because I've already got my turning feature in here with my rough and finish that I just went through. Next, we've got the hex. So we'll bring back my 3D model, because with the milling operations, I can work off of a solid model, select surface edges, or select wireframe. So I'm going to open up the CAD layer again, show that. I would right-click on Machine Setup 1. I would go to Mill Features, and then I'd go to Mill 2-Axis. Go to Select Geometry. Select these 6 edges right here of the hex. Scroll to the bottom and click OK. My next page is where I can select my top of feature and total depth. So I would click Pick Top, pick the top edge of the hex here, and then pick Bottom, will be the bottom edge right here, to pick up my total depth of 1/2 inch. And it starts at negative 150 thou because for whatever reason I have my machine set up at the top of the stock rather than at the top of the part here. So either way, however you set up your machine setup for turning and mill turn, and however you set up your G54 work offset at the machine. And then I'll scroll down to the data entry page down here at the bottom left, and then click OK. And then our next page, we're doing a profile rough and a profile finish. So just doing really basic stuff here. You know, we've got all the other available operations. Next, we'll be getting into doing a pocket on the side of the part. We've got facing for a milling tool, engraving, chamfer mill, corner rounding, plunge rough. I don't think a whole lot of this would be beneficial for mill turn, but especially profile rough, profile finish, and pocket I see pretty frequently with mill turn. So we'll be doing profile rough and profile finish. Our next page, we have options for tabs. Our next page, we have some posting options here. So we can set our work offset number, 1 for G54. We can output in arc moves for any arcs, or we can break up the arcs in tiny line segments with this option. And then down below that, we've got the posting mode we're using. So auto Y-axis mode, I believe, would be outputting, I'm trying to remember, longhand code versus Y-axis mode. Polar interpolation is something totally different, where it gives you a C, I want to say it gives you a C value and an X value based on the polar coordinates of where your milling tool is located around the profile. The Y-axis, I think longhand code just outputs like XYZ values, and then the Y-axis mode is going to, especially since this machine doesn't have a Y-axis, the part is going to rotate around the C-axis. The tool is going to move back and forth in X, positive and negative, to be able to give you the profile around the hex without having to move in X and Y. And I'll double check that in simulation, make sure that's correct there. So multi-axis post, I usually never change anything in here. You can control your C-axis rotation and your A or B axis rotation if you have that in here. And then we can set up our milling tool. So I'm going to go to the top and go to Tool Crib. I have it in station number 8 here. No, I have it in station number 4 here, because that is the correct way the tool is going to be facing. to come down on the front face of the stock and work its way around the hex. So I'm highlighting the tool under station number 4, setting the correct mounting orientation. For mine, it's mounting orientation number 1 to be facing the front face of the stock, going around the hex. So I'll click OK, go to my next page, and all of these are going to be the same workflow as within the milling functionality for 2-axis profile cutting. So there's not a whole lot of a learning curve. It's really just getting into creating the machine setup and some other features for the mill turn, but everything else is going to be what you're accustomed to for your milling features and for your turning features. So you can see here with the cut pattern, you've got the standard cut pattern, contour ramping for a helical ramp down around the profile the whole time, and side roughing, so starting from the outside and doing multiple passes to step over. Next page, you've got your side allowance, leaving 1/15 out for the finish pass to clean up, and doing a single step down or multiple steps down and setting a depth of cut for each pass, setting a lead in and a lead out, setting your corner types, machine sequence, advanced feed rates, and MDI page, just as we have with a profile operation in a milling job. Next page, we're setting up the tool. I'm going to go to the tool crib and select the same tool under station number 4. And this is just a 1/2-inch flat end mill that I defined it as. From the loose category, drag and drop it into station number 4, so it's kind of spaced out from station number 1 with that tool, and setting the mounting orientation there. Then I click OK. Go to my next page, and we have our compensation, we have our allowance, multiple passes, lead in, lead out, corner types, machine sequence, advanced feed rates, and MDI. I'm going to cancel out of this. You can hit compute for yours if you're following along. I'm going to hit cancel because I've got my profile operation right here. And we go to what I did was set up the tool in station number 4. I did a step over of 1/8 of an inch and did a couple passes. I think that's, well, other than that, other than changing anything from default, I also changed my lead in and lead out to a tangent profile. Just kind of fancy there for the rough and finish, doing a tangent lead in and lead out there. Take a look at the toolpath here. You can see where it starts, goes around. Now in the back plot, if I right click on an operation under a feature and go to back plot, I can step through and I can see. Now it looks like the tool is moving in X and Y, but in simulation it's going to look a lot different. And that's especially if your tool's not able to move in X and Y movements like that on the mill turn machine. So now that we've got everything programmed for turning and everything programmed on the front face of the part, now I'm going to rotate around. For some reason, I've got the pocket all the way around here, sort of like on the bottom of it or on the opposite side. But I'm going to go over to the pocket here, and I'm going to program for that one. Now, I can't just go in and right-click on Machine Setup 1 and program for that pocket because the tool from my Machine Setup 1 is always going to be pointed like this. I need it to be pointed, sort of kicked 90 degrees and pointed normal to the surface of the bottom of the pocket. To do that, I would right-click on Machine Setup 1. I would go to Additional Functions, the option below Mill Features and Turn Features, and I would go to Add Index. I can pick a surface, so I'm going to pick this surface for my new Z-axis. You can see that the Z-axis is pointed outward from that surface. That's what I want. If it's pointed inward, for whatever reason, you can click on this reverse button to reverse the direction of your positive Z-axis here. You want your positive Z going outward from the surface there. So you can pick a surface, or you can also pick a UCS. So if this is on the side UCS, you could just pick side UCS here, which it is, but then I would have to reverse it. So those are the two options, either from a UCS like this or from a surface. And it's okay that the index is location is over here, as long as the direction is going correctly. It can be at any direction because it is still referencing the G54 as your machine coordinates. The index here is not changing. So you can see like the X and Y directions are different. I did have to ask that question recently. Just wanted to make sure because that's newer in the newer versions here. The X and Y values, they can be rotated around like that. That is okay because the only thing that really matters here is your Z axis. And everything, again, is referenced from your G54 location anyway. All right, so we've got the index right here. From that index system, I would right-click on it just like I would right-click on the machine setup one to do a milling or a turning feature. So I would right-click on the index system, and here's all of my milling features. You've got drilling and tapping, and I'd go right into 2-axis. I'd go to select geometry, and I'm going to select these edges inside of the pocket here. Basically, all I did to create this pocket, very easy, just created a square somewhere like right around here with a 1/4 inch radius around the corners and did an extrude cut. Very simple stuff for this 3D model to try to get you guys to follow along there. So I select the edges of the pocket, click OK. Next page, we can pick the top of feature, which is going to be the top of my pocket, which is going to be this point right here. And then my total depth is going to be down at the bottom right here. So we're at 3/4 of an inch for the total depth of the pocket. I'm going to click OK. Go to my next page. I'm going to click on pocketing up at the top, which will bring in a pocket and a profile finish pass. My next page, we have tabs. Next page, we have posting and multi-axis post, and then we have our tool page. Now I have to make sure I go to the tool crib, and I'm selecting a tool that has it kicked to the side. So instead of mounting orientation 1, it is mounting orientation 2 for this milling tool. I want to make sure it's not station number 4 because that one's already predetermined for the profile operation for the front face. So I got to use a different milling tool here. I'm in station number 7 with mounting orientation 2, so that if you look at it like that, it's sort of like the turret's going around here, and then it'll come down on the side of the stock like that and do your pocket operation. So I'll click OK, go to my next page, and again, same kind of workflow as I'm doing a pocket operation in a milling job. I have my different cut patterns, my morph spiral, my adaptive roughing, my pocket in, pocket out from the center, step over, side allowance, bottom allowance, multiple steps down, plunge, ramp, spiral into the material, entering into the stock, machine sequence, links, advanced feed rates, and MDI page. And then we're setting up our finish tool. I think I use station number 8 because I'm using a 1/4 inch tool. I'm using a 1/2 inch tool for the roughing. Then I'm using a 1/4 inch tool for the finish operation here. And same orientation, mounting orientation 2. So that is kicked to the side to be able to face towards the pocket. Click OK. And same kinds of options for a profile finish pass, setting my compensation, my parameters, my lead in, lead out, corner types, machine sequence, advanced feed rate, and MDI. Now you can, from here, you can click compute. I'm going to cancel out of this one. I'm going to go back to my feature I already created. And what I'm going to do here, if you want to do this on this operation, or if you want to do this on your previous profile rough and finish, whatever your last operation is for this machine setup, you would go down to the bottom and go to MDI. And instead of going to after operation and adding this part transfer in, we do have some preloaded G code to program everything for a part transfer already. So instead of manually typing it in yourself with this part transfer option on the left-hand side, what I normally do, I highlight after operation, I go down to the bottom right here with the save load option, and then I click on the load icon. And you can see two different features that we have preloaded in the software program. The first one is a generic cutoff transfer, which would do a turning operation with a cutoff tool and a part transfer from the main spindle to the sub spindle. So it's sort of have it on the main spindle, the sub spindle would come over, clamp down on it, do a cutoff, and then clamp on and move it back to the sub spindle. What we're going to be doing today is this generic part transfer. So I would click on that, I would click on open, and it would replace before tool change, after tool change, and after operation right here. And you can see everything under after operation will be was created from that preloaded code there. Now you can see if I highlight each one, you've got everything is named here too. So you start with engage C-axis main spindle. So it does some G code, G and M codes for the main spindle to engage. It also adds some raw text, so it adds a comment in the G code, engage C-axis for main spindle. Next line of code, you have orient main spindle. So spindle orientation, and that would stay at 0 axis, and it says orient main spindle for a comment in the G code. Enable sub spindle, it adds some sort of G code for that, and then a comment saying that it's enabling the sub spindle. So then it orients the sub spindle. It defines the feed move, says, okay, move in inches per minute for the sub spindle, open the jaws for the sub spindle, dwell for 1 second, move the sub spindle to the clearance location off of the stock, then start fast feed up to part. So it moves right to the edge of the part here, 1/2 inch above it. Feed to pickup location, which this is the only number that I've changed in here. I believe it has to do with the location, the length of the stock. Actually, this is feed rate, the one above it here. Where did I change? This is what I changed. So move sub spindle to clearance. I changed this axis value to 7 inches. So basically it's from the back of the stock where that work offset XYZ was, and then moving out 7 inches. And so it's like right at the edge of the stock. We'll be able to see that in simulation to make sense of this number here. Start fast feed up to part, feed to pickup location, close jaws. So the sub spindle jaws are going to close, dwell for 1 second, enable main spindle work zone, enable turning mode main spindle, enable syncing, and then part transfer, and then send spindle home, send sub spindle home. So a whole lot in there. What's really great is that you don't have to create this yourself. It is preloaded in the software program, so you've got a really good template for creating a part transfer operation. You just hit compute, and then you'll be able to view it in simulation. So what, excuse me, what I would do first, I'd save my progress, go here to the top and start simulation. And so here is the BobCAD 2-turret, 2-spindle machine. If you don't see it yet, it's going to be at the top left here of your simulation. Drop that down. Normally it's at workpiece stock or tool. You'll see some tools floating around with the stock, or you'll see, that's about it. So you change it to machine, which will have the 2 turrets, the 2 spindles. You can see that the stock is sticking out the 6 inches that I defined here. And it's going to load in some jaws once I hit run. I'm going to slow down the run speed of simulation and then hit run. So here's our facing operation. Next we have our turning operation, roughing on the OD. It'll take a few seconds because it's doing a depth of cut of 50 thou, and then it does the finish pass. And then it does the milling on the hex. Now you can see the tool isn't going to move in X and Y around the part here. And the reason for that is because this machine does not have a Y-axis movement capability. It does have X and it does have Z axis capability. So it's coming down in Z to the total depth here. And then it moves back and forth in X. You can see the coordinates right here, back and forth in X like that, inside to outside. And the part rotates around the C axis to give us this hex here once it starts cutting eventually. Looks like I needed to do less step overs. There we go. So now it gets in to the cut. So you can see moving back and forth in X and rotating around in C will give you that profile cut that you need, that linear amount. I guess you could say that linear cut by rotating the part around. Pretty cool stuff. And now it's doing the profile finish pass. After the finish pass, we are getting to the pocket and then profile finish for the pocket. So here after the profile finish, changing tools, coming down onto the pocket with the tool kicked 90 degrees from our profile for the hex, doing multiple passes or multiple steps down into the pocket here, down to 3/4 of an inch depth, and then using the 1/4 inch tool for a profile finish pass. Oh, let me try to restart it here for that part transfer. So let me get back to where we were. I'm just going to hit next op up at the top here until we get to that last profile finish. Oops. For the pocket, and hit run. So here's the profile finish again, and then it's going to, you can see it's just sort of clamping on very barely with the jaws here, clamping on, and then you've got your sub spindle with the jaws here. And I'm just going to hit step forward up at the top here so that we can see very clearly the sub spindle moving across. You can see the jaws are open. You can see it gets to the correct location. You can see it clamps down. And you can see the part transfer and then the sub spindle moving over. The jaws are open for the main spindle. Jaws are closed for the sub spindle. And then we can go about creating a machine setup on this side for the sub spindle and programming for that side. So we close out of simulation. Next, I would right-click on Machine Setup 1. I would go to Additional Functions, same location where we have Add Index. I'm going to add a new Machine Setup. That's down towards the bottom, Insert Setup. Click on that. We've got Machine Setup 3 technically, because I already had Machine Setup 2. So I'm going to rename it just to make it simpler for us. So I got Machine Setup 2. I right-click on Machine Setup 2. I go to Edit the Machine Setup 2 first, because right now we're right here. I want to flip it over. I want to click Origin, click on the point here, and then reverse the directions for my Z direction specifically. And so if I'm looking at it like that, Z-axis going out, X-axis pointed up. And then other than that, I can change my work offset again here because, we're sort of considering this to be the sub spindle now, and we want to move it out of the sub spindle. So I'll do that 6 here. And up at the top, I'm going to change it from left spindle to right spindle. And I think that's it. There should be, I thought there was another one for setting up the turret and the spindle, but that's looking all good for now. We'll click OK. I want to make sure everything is referenced correctly from my Machine Setup 1, Z-axis out, X pointed up. Machine Setup 2, Z going out, X-axis pointed up in the same direction as Machine Setup 1. And then I would right-click on Machine Setup 2, go to Turn Features. Let's do a drilling operation first. So I'd go to Turn Features and go to Lathe Hole. I can select my geometry. I can select a hole like this, or I can just select the center point of the hole right here of my depth to pick that up. It's a total depth of 3/4 of an inch. And I'll say the diameter, let's go with a 1/2 inch hole here. It's not a through hole, it is a blind hole. We'll go to our next page. We'll do lathe hole, which will add in a center drill and a drill. And then posting, up at the top here, we've got separate moves or can cycles for all of our turning operations. And we also have the sub machine. So UT stands for upper turret, MS stands for main spindle, LT stands for lower turret, and SS stands for sub spindle. So if I select upper turret, I don't think I'm doing upper turret, I think I'm doing lower turret. I think I'm going to do lower turret, and I'm making sure I'm doing the sub spindle specifically here. Go to our next page. We set up our center drill by going to the tool crib, and now you can see we have lower turret labeled up at the top. We have no tools in any of the stations here for the lower turret yet. So I'm going to start with the number 5 center drill, drag and drop it into, let's go with station number 20. And I think in relation to the sub spindle, this is the correct direction. I may have to switch it from 1 to 3, but I think this is correct. And I'm going to move it out of the turret a little bit in the Z-axis. I'm going to move it out 2 inches in the negative Z direction. Then I'm going to click OK. I'm going to go to, setting my plunge feed rate, the dwell time, all those settings there. Go to parameters and set my depth for the center drill. For all of our drilling options now, including center drill, I think like reaming and chamfer operations, boring operations, I think, we've got single depth, peck, and fast peck. So even with a center drill, you can peck or fast peck with those here. And some of the other drilling operations I know too, newer stuff. Tapping as well. We've got PEC tapping too. So then our next page, we've got rapids. We've got MDI for manual data input. Then I set up my drill. I'm going to have to drag and drop it from the loose category. And let's go like halfway over almost. I'm in station number 26. Same mounting orientation and same shift, axial shift right here on the right-hand side. I'm going to move it over 2 inches in the negative Z direction. And then click OK. Next page, again, PEC or fast PEC. I don't think I want to go any further necessarily. That's okay. Overall depth. Yeah, I'm going to change it to 3/4 of an inch. I'm being a little too fancy there. Okay, so overall depth, 3/4 of an inch, because that's the total depth there. I don't want to plunge past that point. Then we've got rapids and MDI. I'm going to hit compute. And here's our toolpath. Here we'll take a look at the backlot. Just sort of drilling in, and then I would use a boring bar to do the ID work from there. So we'll take a look at simulation. There may be something I need to change in terms of the distance in simulation, but as long as the backplot looks correct here, all of the G code would be correct in posting it. So if we start with that, we would just go to the top and click post. It'll generate the G code here in the posting window. I can see all of the tools in here for my BobCAD 2-turret, 2-spindle machine. Got the first machine set up and the first tool. Scrolling all the way down to the last page. To look at the G code a little bit as well, if we look at the profile for milling, we're in turning still. 2-axis profile. So in 2-axis profile, this first one for the hex, under posting, we are in longhand code. So it's outputting X movement and then C-axis rotation for the profile. If I change it to auto Y-axis mode, it's saying that there's an over travel of doing that one. And then if I change it to polar, polar is going to be a little different, I believe. Let's see, 2-axis profile rough, is that right? Lathe turning, basic finish, and then profile rough. And so with this one, these are polar coordinates where it has X coordinates, C coordinates, and then I and J values as well. So the polar coordinates are a little different. If you look at it like this, it's like from the center of rotation 1.1 inches out, and then C of your C-axis location of where the tool is. It's a little different for your polar interpolation than it is for the longhand code there. But anyways, let's see what we have so far. I'm going to simulate what we have and see how that looks on the sub-spindle. I think it should work for us, hopefully. Well, if I look at the simulation, it looks like the tools are not located in the correct direction. But take a look at it. We'll step through all of these operations to get to the part transfer. So we've got that profile finish pass, the part transfer, and it's trying to work on the main spindle still. That doesn't look very good. That would not look good in real life if your main spindle and your sub spindle just crashed like that. So that's what simulation is good for. So we've got upper turret. Oh, I want lower turret sub spindle here. So that is, I'm changing the machine under machine setup 2 here. I missed that right there. And then it says, do you want to update all features below the setup to the selected submachine? Yes. Let's see if that has made any changes for me. But again, what I'm working on right now is all just simulation purposes. I can always post it, and if you have the graphics on the machine to be able to look at the G code for your machine, be able to look at that on the controller, you can definitely do that. But now I'm just making sure that simulation looks good. So that's looking correct, except for the fact that the tools aren't pointed the right way. So then I would go in and I would change. Let's see if there's anything I need to change here other than mounting orientation. Submachine is lower turret sub spindle. I might just move it to the upper turret, but let's see. Substation side face, yeah, that looks correct. So I'm going to change it from mounting orientation from 1 to 3. I'm going to change the axial shift from -2 to +2 in the Z direction. And do the same thing while I'm here. I can highlight the 1/2-inch drill. I can change it from 1 to 3, change the axial shift as well. But once I click on OK, it's going to say incorrect tool type selected. Please select another tool. So just to let you guys know, you can change the tools of other operations in the Mill-Turn tool crib at any time. You just got to make sure you go back to your number 5 center drill or whatever tool you're using for this specific operation that you're in the tool crib for. All right, so let's try out simulation from there. Clamp. And there's the drill. Looks like it's missing just by a little bit. I'm not sure why that is. There are some parameters that can be changed to for that. Now with machine setup 1, I think everything is okay. We've got the work offset XYZ. We've got the sub spindle in Z of 7. This is the same as in the MDI page. And the spindle park position 30 inches away from the main spindle. We go to machine setup 2. We have our work offset. I wonder if I set that to 0, that might. But it's one of those 3 numbers that we can change for the distance from this front face to get the drilling operation looking correctly in simulation. The work offset XYZ, the Z distance right here, then the sub spindle in Z, and the spindle park position. I think I either have to have the work offset XYZ and the sub spindle in Z both at 0 or both at 6. So let's test both of those out. But it's a good, sort of a good troubleshooting lesson, I guess, at the end of the webinar here. If you guys have any questions during the live event today, please let me know. We're almost finished with the live event, just as long as I get the the sub spindle coming out of the main spindle here, getting it to work. And yeah, if you guys have any questions, please let me know. Just have the work offset to move right here, and I think maybe the spindle. There we go. Still not. I think what I could do is I could move it that distance with the work offset. So let's try try 9. But yeah, I'm just messing with the numbers now to get it exactly correct for the drilling to the top of the stock there. What can be really helpful with those numbers, I can show you guys that as well because these get pretty complicated. If you go to File and go to Help, go to BobCAD-CAM Help, and we do have documentation on what all of these numbers are. Let me just check to see if I got it right yet. Anyways, if we go to the BobCAD-CAM Help, go here to CAM, go to mill turn, and go to where would it be? It'd be lathe operations? No. It would be you'd think there'd be like MDI. No. You can type in part transfer right here. And it will bring you to the right page. I know that. So we have mill turn transfers. And it tells you, like, if you've got the 1 turret, 2 spindle, sub-machine naming, example part, shows you the machine setups like we did here. And it will tell you the work offset values in Z, the sub-spindle Z, and the spindle park position. Now it's the distance between the stock and how far you're pushing it out for your work offset Z, as we mentioned here. And then it gets into the distance from the jaws, and then the distance. See, I mean, you have a whole lot of documentation right here to get that distance correct for the drilling. Edit the work offset sub spindle Z value, which is the next value, and then the spindle park position as well. So a lot of great documentation under BobCAD-CAM Help, and typing in part transfer is the first search topic there. But you have your simulation, and you also have your backplot. As long as your backplot is correct like this for drilling, for the tip of the tool, which is your location of the tool, configured with your new G54 or G55 location, then that would be the correct setup for your machine. All of those numbers that we're looking at under the BobCAD-CAM help system is mainly for simulation purposes only. And once the simulation is all correct, you've got your drilling and turning on the ID. Again, you just hit post. You would right click on the posting window here and save it as an NC file. Save it onto a flash drive or save it onto a network drive to send it over to the controller. You also have the capabilities, we'll get into that real quick, of the NC editor. If I right click on the posting window, go to NC editor. This is where you can modify the G code. Everything here is color coded. You have your comments here in green. X, Y, Z moves are different colors. And then you can go to tools up at the top. You can see that. You go to tools. You go to start DNC transfer. And you can set the port number, the baud rate, and all of those settings to send or receive from the machine with an RS-232 cable. These are the same settings you would be familiar with in Predator software that we used to have. Now we've got our own NC editor that we created with the port number and baud rate settings, and then the character delay and line delay for drip feeding. And that is it for the topics that we're going over today for mill turn. If you guys have any questions with what we've gone over today, please let me know in the comment section here. I want to thank everyone for viewing the live event today. We're going over mill turn today. And we do a webinar like this every other Wednesday, 1 o'clock p.m. Eastern Time. So today was mill turn, and our next one is going to be Wednesday after next on December 18th. And the topic is TBD, to be determined. We always send a survey out after the webinar and try to make sure that we have these webinars tailored to exactly what you guys are looking for. I know mill turn, a little sparse for the people coming out today, just because it's a much more complicated and technical topic. So I'm glad everyone was able to view the live event today, people that wanted to see this topic. And then again, we send a survey out to make sure that the next one is whatever you guys want to look at. Thank you, Leon, for viewing the live event today. Thanks for your comments today, and thank you everyone else as well for viewing the live event today. We hope to see you in the next one, December 18th, 1 o'clock p.m. Eastern Time, and hope you guys have a great rest of your day. Thank you very much. See ya.